Hi everyone, Mrs. V here, and today we are back on the organic nomenclature. So today we are going to learn how to name carboxylic acids. So let's get the whiteboard on and get straight to it. Carboxylic acids are pretty easy to name because they're named in pretty much the same way that aldehydes are. The IUPAC term for carboxylic acids is alkanoic acids, and they are given the suffix of oic acid. So it's always something methanoic acid, ethanoic acid, propanoic acid, etc. The functional group present is the carboxyl group, and it's called the carboxyl group because it's a combination of the carbonyl group, which we see here, and the hydroxyl group, which we see here. The carboxylic acid group is a terminal group, and we saw in the aldehydes that a terminal group always has the number 1. So the carboxyl carbon is, not surprisingly, the carbon that's in the carboxyl group, and that always has number 1 in your numbering of the carbon chain, and then we just list the attached groups in the usual way. All right, so let's crack on straight away with some examples. So the important thing we need to remember is that the carboxyl carbon is one of the carbons in the carbon chain. So that's the trap for young players in this particular naming. So in this case, all we've got to do is find the longest continuous carbon chain that contains the carboxyl carbon. So in this case, we only have one carbon atom. So this one is methanoic acid. All right, the next one. Now, I really don't like structural formulae or skeletal formulae that use the terminal, show the terminal carbons. So this is 1, 3, OH. Here's the carboxyl carbon, and there's a methyl group here. So we've got to find the longest continuous carbon chain that includes our carboxyl carbon here. So this could go straight across the page, or it could have gone including the methyl group. So we could have actually gone this way. Good news is it does not matter one little bit. If there are 2 ways to get that longest carbon chain, it doesn't matter. Now, numbering the chain, the carboxyl carbon has to be number 1. It's number 2, 3, 4, and 5. So this is a pentanoic acid, but we have a methyl group here on carbon number 4, which makes this 4-methyl, 5 is pent, so pentanoic acid. All right, your turn. Pause the video, have a go at this one. Okay, so here's the carboxyl carbon. Let's find the longest carbon chain that includes that. So this would be this one here, which means that this chain is 1, 2, 3, 4. So that's a butanoic acid. Again, we have a methyl group attached, and it's attached at number 2. So the name of this one is 2-methyl butanoic acid. The only thing that gets really tricky about this is just the way the molecule is actually written out. So sometimes you'll see in this next example that the carboxylic acid group is separated out just to really let us know that's a carboxylic acid. In this case, it's really easy to forget to include the carboxyl carbon in the carbon chain. So just be careful about that one. Once we know to do that, though, we can circle the longest carbon chain, number it. So this is number 1, 2, 3, 4. So this is another butanoic acid. And this time we have a bromo group. This is a bromo. We have a bromo group on number 3. So this is 3-bromo butanoic acid. Lots of examples with butanoic acid. If you've met butanoic acid, you will not forget it. That is the acid that smells like vomit. It's disgusting. Most of the carboxylic acids smell disgusting. All right, let's look at the next one. This is, again, just trying to trick you with a really complicated layout of the carbon chain. But don't be tricked. Identify your carboxyl carbon and then make sure that you get the longest carbon chain that includes that. Now look at what's attached. So we have 1, 2, 3 methyl groups. Number the chain. 1, 2, 3, 4, 5, 6. So this is a hexanoic acid, and it's a trimethyl hexanoic acid, and the 3 methyl groups are on 2, 2, and 5. Remember that every methyl group has to have its own number. So it's 2,2,5 trimethyl. You can't just say 2, 5. Okay, you've got to say exactly where every methyl group is. And then we have hexanoic acid because of the 6 carbon atoms. Now, how do you handle it when there are 2 carboxylic acid groups on a molecule? So here we can see we've got a carboxylic acid group on each end. Well, all you've got to do in this case, this is a dicarboxylic acid, and you need the longest carbon chain that actually includes both of those. So the longest carbon chain is 3 carbons long. So that is prop. It's a dioic acid, so it's propandioic acid. You don't need to put numbers in because so propandioic acid. Because the carboxylic acid group is a terminal group, you need to make sure that you don't put numbers in, because it would only be on 1 and 3 for propandioic acid, because they have to be on the end. So it's actually wrong to put the numbers in if you don't need them. Now, one of the things that we come across with carboxylic acids is that they're actually often referred to by common names rather than their proper names. So it's handy to know few of the common names. Even though we know we are IUPAC namers, we know the rules, we follow the rules, but unfortunately society does not follow the rules in all cases for carboxylic acids. So a few that it would be useful to know would be very useful to know that methanoic acid is called formic acid. I'm sure you already know that ethanoic acid is called acetic acid. And benzoic acid. Benzoic acid is a benzene ring with a carboxylic acid hanging off of it. So a whole heap of acids there that are referred to by common names. Propanoic acid is also called propionic acid. Butanoic acid is also called butyric acid. So just having a bit of knowledge of those common names helps you understand sometimes what people are talking about. That's all we've got for you today. If you found this video useful, or you just enjoyed a bit more organic nomenclature, then please consider giving the video a like. Also, if you would like to find out more about this awesome subject of chemistry, then please subscribe to my channel and watch a few other videos. Until next time, stay safe and enjoy the chemistry.